In the previous examples, we have seen that the total distance traveled is the area underneath the velocity curve. If the function is linear, we can use geometry to solve for the area underneath the curve. So in example 3, a particle starts at x equals 0 and moves along the x-axis. Where is the particle when t equals 6 if the velocity is v of t equals 1/2 t? If the velocity was constant, we could just multiply the rate times the time traveled. But because the velocity is not constant, it gets a little more complicated. So the first step is to go ahead and graph the function. So we want to graph. So since this is a line, 0 to 6, I'm going to plot the points 0, 0, 6, 3. And I'm going to connect those with a line. So this is the graph of 1/2 t. So what I need to do in order to find the distance covered is to find the area of this triangle. So my goal is to find this highlighted area. Well, it's actually not too complicated. It's not too bad. But we want to make note that the area under the velocity curve and the x-axis is the distance traveled. So it's a triangle, so we know area of a triangle is 1/2 base times height, which is 1/2 6 times 3, so it's 9. So the particle is at x equals 9. And that's it. If I want to find where the location of the particle, all I do is find the area underneath the velocity curve. So I want you guys to try this one on your own. Take a second, pause the video, and determine the position if the velocity curve follows the pattern 1/2 t plus 2. Okay, let's see if we got it right. Well, we know that the y-intercept is going to be 2, and then when you plug in 6, you're going to get 5. So I go ahead and I connect those with the line. And then what I do is I draw a line straight up from 6. And my goal now is to find this area which is underneath the curve. So my goal is to find this highlighted area. Well, there's two ways you could approach this. One way is to take this area and split it up into two shapes. So doing this, you're going to get a rectangle that's 2 by 6 and a triangle that's 6 by 3. So then the area is if I find the area of the triangle plus the area of the rectangle. So that's 2 times 6 plus 2 times 6 times 3, which comes out to 12 plus 9, which is 21. Another way to do that is to recognize this being a trapezoid. So you get a trapezoid. And so the area of a trapezoid is height over 2 times b1 plus b2, where b1 and b2 are the bases. So the height of this trapezoid is going to be 6 over 2. And then the first base is 5, and the second base is 2. So area is equal to 3 times 7, which is also 21. So the particle is at x equals 21 after 6 seconds. And that's it.